Okay, I presuppose that all of you have gone through the question, you have attempted it, and now it's more or less like a matter of presentation. Okay, so let me just pick someone. Okay, so to do it for us, Faith. 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 Hey, Faith, you ran away. What happened? Hey.
Yes.
Yes, Faith.
Yes.
Yes. Can you take us through part?
Yes.
You can take us through part 1.
Yes.
Okay, fair enough. Take us through.
So the question was asking we get the portfolio expected return.
Yes.
We did.
Wow.
We
yes.
calculated the weight.
You did the weight?
Pardon?
Oh, I lost your Faith.
Yeah, where we took 4 divided by 4 plus 6 to get the
Wow, Faith, I lost you. I don't know whether it's my network or your network. Yes.
We calculated the weight of C and
Wow, I totally lost you, Faith. I don't know. I think it's my network or your network, maybe, that has issues. What was your group? Who was the other group member? Maybe I can just check out with them. And let me pick someone else because I don't know. I lost your connection, Faith. Asma. Okay, let me ask Asma. Asma, you can take us through. Asma. Asma.
Yes.
You can take us through.
Okay, question Roman 1.
Yes, Roman 1.
Okay. For the portfolio expected return,
yes,
we read the formula. The formula is WA, WC, RC.
Sorry, the formula is W.
WC.
W weight of C. Okay.
Weight of C times return of C.
Return of C, yes.
Plus weight of S.
Weight of
times,
S.
Times return of S.
Return of S. Okay, fair enough. We'll proceed.
And then we get the weight of C and S, which is the amount you've been given, the amount invested, which is 4 million and 6 million.
So 4 million for C and 6 million for S.
Yeah, but you get the total. You add the two, you get 10 million. So you can get the weight.
So weight of so weight of C is 4 million out of 10 million.
10 million, yeah.
To give us 0.4.
0.4.
Okay, weight of S is how much?
6 million divided by 10 million.
Divided by 10 million to give us?
0.6.
To give us 0.6. Proceed, true.
And then you replace it, you substitute in the formula, the return of the expected return, the portfolio expected return is equals to 0.4.
Okay, so the return, what's the return of C?
Oh, return of C is 11%.
11%, okay. So the return of the portfolio therefore will be equal to
0.4 times 11%.
Times 11%, sure.
Plus 0.6 times 25%.
Times 25%, the return of asset S, sure.
And then you'll get the portfolio expected return is 19.4%.
19.4%.
Yeah.
Okay, thank you, Asma. Okay, we get 19.4% of the return of the entire portfolio. Okay, that is 40% investment made in C and 60% investment made in asset S. Yes, okay, thank you, Asma. Okay, now let's pick, let's get someone else to see. Okay, to make us Maureen. Maureen. Hey, Maureen went away.
Yes.
Yes, Maureen.
Yes.
Okay, you can take us through Roman 2.
The portfolio risk.
Yes, the portfolio risk.
We are given the standard deviation,
Yes.
and we already have the weight.
Yes.
So the standard deviation we will square. We will only look for the covariance.
Okay, so we look for the covariance between C and S. Okay.
Yeah, between C and S. So the covariance, we already given the coefficient.
Yes.
We have the standard deviation.
Yes.
And we have the standard deviation for C and S.
Yes.
So the covariance will be the coefficient times the standard deviation for C.
Okay, just a minute. Covariance between C and S will be equal to?
The coefficient.
Between C and S.
Yeah.
Yes.
Times the standard deviation of C.
C, yes.
And the standard deviation of B.
Standard deviation of S.
Yeah, of S.
Of S, okay. To give us?
Yeah. A minute. To give us 90.
Also, the coefficient is 0.3. Standard deviation of C, I'm just trying to multiply, is equal to 0.15 times standard deviation of S, which is 0.2. It'll give us how much?
We found 90.
90%.
But it seems strong.
Yeah,
so it will be 0.9. It will be 0.9.
0.9.
Yeah.
0.9. Okay, the others confirm just in case it's not the correct. Okay, so 0.9. So we get 0.9, therefore to be the covariance between C and S. Okay, fair enough. Okay, so now we can apply the formula.
Yeah, now we can apply it to our formula.
Okay, let's set the formula. Okay, so anyway, so the formula is equal to, I presuppose that you all remember the formula. So let me just write down. Okay, so weight over set C squared, variance over set C, okay, plus weight over set S squared, variance over set S, plus 2 weight over set C, weight over set C, weight over set S, sorry, weight over set S, okay, times covariance between C and S. Okay, I presuppose that you already know that formula. Okay, let's plug in the figure.
So it will be 0.4 squared.
0.4 squared, okay, times?
Times 0.15 squared.
0.15 squared. Don't forget the figures given here are standard deviations. To get to the variance, then square. That's true. So 0.15 squared, sure, plus?
Plus 0.6 squared.
0.6 squared.
Times 0.2 squared.
0.2 squared, sure.
Plus 2. 2 times times 0.6.
0.6.
Times 0.4.
Sure.
Times 0.9.
Times 0.9. The covariance between C and S. The covariance between C and S. Okay. C and S. Okay, fair enough. But just multiply. There's nothing else. You just apply the formula and you get how much to be the variance of the portfolio.
My answer is wrong because I used 90.
Oh,
so
because you used 90. Okay. Someone who used the right figures, what did you get? Okay, thank you, Maureen. Okay, Louisa. Is Louisa? Yes, Louisa.
I just wanted to say that her method is still correct, only that now it will be 0.009.
Oh, it was 0.0, not 0.9.
Yes, and
so
it will still give us.
So the covariance here should be 0.009, that way.
Yes.
Okay, so here, so let me just remove this. So 0.009, that way.
Yes, because I also did the 90 and keeping the percentages. I didn't do 0.15, I did 15, just like she did. And I got the same answer, being 14.94.
Oh, okay. So get 14.94% now.
Yes.
Okay, whether you use percentage or use decimal, okay, fair enough. All the tell us the same thing. So 0.9% squared. That way, that's the variance of the portfolio.
Yes, 14.9.
Okay.
No, that's the standard deviation. The variance was.
The variance was how much? The variance was?
Okay, now I also used the numbers in whole, and I got to 23.2. I guess, let me just check. In that way, it will be 0.02232.
So get 223, 223.2.
223.2.
223.2% squared. Okay, so therefore you get so deviation therefore is going to be the square root of 223.2 to give you how much?
14.94%.
14.94%. Okay. 14.494%. Okay, I presuppose that everything is okay. Okay, thank you, Louisa, for that. Okay, thank you, Louisa, for that. Someone else, someone who had his hands up. Let me check. Stacy. Stacy.
Okay, I've seen it.
Yes.
I've understood it.
You understood it. Okay, okay,
Yeah.
okay. Thank you. Someone else was asking the variance. Okay. Now, Janet, okay, I don't know. I'm trying to go through the chat and I seem to understand the question, as well as for the innocent variance. Innocent, can I unmute you? You attempt to explain it to me. Let me see if I can go to help you out. Innocent.
Okay, I'm getting the variance as 2.232%.
Or 2.23%.
Yes.
What did you use? What did you use in the variables or the formulas? Weight of C was 0.4. You used decimals, isn't it?
Yes, I use decimals.
Okay. So where could you have? Look at the formula and our formula. Where do you have the difference? Could there be?
Actually,
yes.
It's the same thing, but the answer is supposed to be 2.23.
Oh, it's the same thing, but the answer is meant to be 2.23. Okay.
Yes.
Okay. Now, I don't know how. I don't have a calculator, so I don't know where. And your variance is 0.009.
Yes, my variance is 0.9%, which is 0.009. The covariance, that is.
Covariance, that okay. Now, I am not sure where they seem to. Let me see, maybe someone else did realize a mistake. Lois.
I think those who used decimals,
yes,
their answer is not in percentage.
The answer is not in percentage. So what do they get?
That time I get it 2.232.
On the one who used decimal, they get 2.23.
Yeah, without changing it to percentage.
So you get 2.23 that way.
Yes. Without the percentage.
Without the percentage, okay. And if you get square root, you get what?
You get now 1.494.
1.94. But why?
You
what? Oh, okay. Unless it's a mistake somewhere, because even if you use decimal, we ought to get 0.1494. So in case you get in 1.494, then it's something wrong somewhere on our formula somewhere. Then because this, don't forget this 14%. This is 14. Let me just highlight it. This is 14%. Okay, this 14%, which is meant to be 0.1494. Once we convert it, therefore, is meant to be 14.94%. So in case you don't get this, then there's something wrong somewhere. I don't know. Let's think someone else could have had an idea somewhere. Stacy.
Yeah, hi.
Yes, Stacy.
For me, I used the decimal points.
Yes.
And for the standard deviation, I got 0.02232, which is
yes. So you got 0.02232. 2232.
Yeah,
okay.
Which in percentage is the 2.232%.
Okay, and the square.
When you find the square root of 0.02232,
yes,
it's 0.14939. Okay, it continues.
Yes.
And it's 0.1494, and then you multiply by 100 gives you 14.94%.
Get 14. Yes, that's how it's meant to be, because unless maybe for those, I think the one who got 2.232, then maybe you may want to check whether you may have made some mistake along the way in your calculation. Because even if you use decimal or use percentages, we ought to get finally the same answer. Okay, but in case you use decimal, you get 14.94. Of course, converting back to the decimal, we get 14.94%. So unless check the one who got the 2.23, check maybe there's a decimal somewhere along the way you may have forgotten. Maybe let me check. Maybe there could be someone else who have an idea. Mosoti.
Yes.
Yes.
It's the same thing what CC said. So
yeah. Okay. So maybe those who have 14 point who have 2.23, check maybe you may have made some maybe simple calculation somewhere. Who is this else? Sharon. Sharon.
Yes, I think.
Yes.
I think the problem is like if you had used them as decimals, if you use like now where it's 0.9%, like I used the 0.009. So when you get 0.02232, when you get 0.02232, you shouldn't make it into percentage again. That's why I think the problem is.
That's why I see.
Yeah, if you make it percentage,
yeah,
you'll get the 1.494.
Yeah,
and I think that's where the mistake is.
Yes, I see. Okay, thank you. Yeah, don't forget, don't convert here. Maybe thank you for highlighting that. Don't convert here. Don't make it into a percent here. Don't make it to a percent here. We can make it percent on the standard deviation level, but not on the variance level. Thank you. I was trying to wonder where the mistake would be. Yeah. Don't make it into a percent level. Don't make it into a percent on the variance level. Okay, you can make it into a percent on the standard deviation level only, not on the variance level. Okay, because we are squaring those percentages, we are squaring those decimal places, and on the variance level. Okay, for the standard deviation, you can convert back to to percentages, but not on the standard deviation on the variance level. Okay, I was also confused why you guys are getting different answers altogether. Okay. Yeah, I think the same has happened. I think people have realized it. Yeah, thank you. Okay, and that's how, therefore, we do get the standard deviation of the portfolio. The standard deviation of the portfolio. Okay, I think for sure, definitely, you need to think you have to remember the formula. I think that's the most crucial bit of it. Okay, you have to remember the formula. Simple as that. Okay, and then you simply be applying them. Okay. And more or less, I think that's marks the end of risk and return. That marks the end of risk and return. Okay. If any question, you let me know. Okay. Now I want us. Okay. I think we can begin with a new topic now. Okay. Unless you have a question, I guess I don't think there's anything else that is too straight. Okay. Yeah, some question here. Let me check. From who? This is from Michelle, I presuppose. Michelle.
I'm asking, is the covariance 0.9% or 90%?
Is it 0.9 covariance? I don't know. Do you want to use percentages or do you want to use decimal places? I think it depends on what you want to use. Because for those who use percent. You want to use percentages?
Yeah.
Yeah, then in case, okay, I hope you can see my. So in case you use percentages, then to be 0.3 times 15 times 20. And you get how much? I don't know what to get. You get 90.
90, yeah.
You get 90, yeah. Okay, yeah, then fair enough, you can use 90. But don't forget this covariance. It will be 90% squared. Okay, to be 90% squared. Then of course now you can plug it in here. But don't forget, if you have to use decimal, then use decimal throughout. If you want to use percentages, then use percentages throughout. It's clear, Michelle. Michelle, it's
okay,
clear.
It's not clear because in the chat, when you look in the chat, people are saying it's 0.9, others are saying it's 90. So I'm confused.
No, Now, what do you want? You guys, okay, let's put it, we put it clear here. If you want to use percentages, use percentage throughout. If you want to use decimal places, then use decimal places, okay? Only convert if you are doing the standard deviation. Don't convert before that, okay? So don't convert before that. If you want to use decimal places, then use decimal places throughout from the beginning until the end, okay? Only convert when you are discussing or when you are converting to standard deviation, not before that. Okay, I think so that you avoid confusion. Okay, if you want to use decimal places, then use decimal places from the beginning until the end. Only convert at the standard deviation level. Okay. Now let's see where it is. Who has his hand up? Innocent. It's a new question. Innocent.
Yes.
Okay. Okay.
Mine is just a clarification.
Yeah.
So if I think from my end, I think the covariance is supposed to be 0.9 because
0.9.
0.9%.
0.9%. You use percent. Do you use percent?
Percent. Yes.
Are you sure? Because 0.3 times 15 times 20, it won't give you 0.9.
If you take 0.3, remember so it will be over 10,000. It will be 20 divided by 10,000.
Wow. Okay, I lost you, Innocent, somewhere along the way. Sorry, just repeat.
Okay. I'm saying
yes.
It will be 0.3 times the 15 over 100. There are two denominators over 100 over 100, so it will be over 10,000.
Also 0.3 times 15 times 20 divided by 10,000.
Yes.
And you get how much?
That will end up giving you 0.9%. That will be the percent.
No. Innocent, don't convert. Don't convert into a percent. Don't convert. If you want to use decimal, use decimal. Don't convert into percent. If you want to use percent,
okay. Pardon, sorry for interruption. If we give the decimal, what will we be getting? 0.
No, actually, it becomes hard for you to make an interpretation. At that level, you don't have to make an interpretation. So don't convert this into a percent. Don't try to convert this into a percent. So don't attempt to convert, because this is, don't forget here, if you have to use percentages, this is percentage squared. Now, what does that mean? It becomes a lot, you can't even derive a meaning out of it, okay? But I'm trying to say that in case you want to use percent, okay, like we have done here, okay, then use percent throughout, okay? If you want to use decimal like I've done here, then use decimal throughout. Don't mix them. Don't try to convert this 0.009 into a percent at this level. Don't convert it. The conversion only happen, okay, when you are discussing on the standard deviation. So because the conversion along the way won't make any sense. Don't forget that the same applies to the case of the variance. You can't convert, because what are you going to get? Don't forget here, it is 222.32% squared. Now, what does that figure? You can't get a meaning out of it, or you can't get meaning out of that figure. However, in the case of standard deviation, you can get meaning now. You can get meaning out of it now. Here, that's where you can convert from 0.149 into 14.94%. That you can convert. But before that, don't make a conversion. Okay, so don't make a conversion at this point. That's what I would suppose that you avoid as much as possible.
Okay.
Innocent, I hope it's clear.
Okay, so I have seen the difference is the percentage squared.
Yes, percent squared. The percent squared. That's true. The percent squared. And here, don't try to get meaning out of it on the covariance side, because you will not get a meaning out of it. The only meaning you're going to get is both this a positive or is a negative. Nothing else, by the way. That's the only meaning you derive out of the covariance. Either it's a positive or it's a negative. But otherwise, what those other figures imply have no economic meaning out of them. Okay, so don't try to convert them into okay, you can understand. Of course, you can try to get the meaning that in case the figure is quite high, then of course that means more risk. But you can't be able to scale it. Okay, so the meaning is a bit diluted by the use of covariance and the use of variance. Okay, I hope it's a bit clear. Okay, so don't convert before. Convert only at the standard deviation level. If you use percent throughout. If you use decimal, then use decimal throughout until the level where you want to get now, the standard deviation Then there's someone else who had. No, I'm not sure whether, because no, they have too many hands up. So let me know which one I have answered and which one I have not answered. Because so in case I've answered, you can lower your hand. I think there's an icon there where you can lower your hand. So I'm not sure. I think David.
I think you've answered what I wanted to.
Okay. Now I'm not sure whether I've answered Sharon, Stacy, and Let me lower your hand so that I can get to know who it is. I've not answered the question. I'm trying to lower your hands, all of you. So in case I've not answered, let me know. In case I've not answered the question, let me know. Okay, so let me check on the chat. Okay, that was I think what we were discussing before. Okay, and that's how we determine risk and return. That's how we determine risk and return. Now, guys, I don't have power, so you and my computer might shut down anytime from now. It seems not to have power from my side. So I will presuppose, okay, that you can start signing just in case my power goes off, just in case my computer shuts down. Anyway, hoping it won't shut down. We can continue. Yes, Amolo. Look, let me check. Look. Michelle, this is a new question. Michelle?
No, it's not.
Ah, okay. So, Luke, where is Luke? Yes, Luke. Luke?
Let me take you back.
Sorry?
Are you getting me?
Yes, I can, but I lost the question.
Where we were later.
Where we were? Look, I can't
get... The question is...
Yes, the question.
I'm asking.
Yes.
For the formula.
Yes.
For the
formula for?
Population and sample. The N. What does it stand for? Is it the sum of N1 and N for getting covariance for population and sample? Yes.
Which formula? Because there are quite the number of formulas.
Is that N for the sum of the N of, yeah?
No, okay. I don't know where you are saying N.
Where we were getting the covariance.
The covariance. Let me just go there.
Of a sample.
Covariance over. What does N mean?
When we are getting covariance of a sample.
Yo, so you're asking what does N mean?
We didn't do it today. Yes.
Okay. Let me just
go through. Is it the sum of N of A and N of B or?
Just a minute. Let me just go there so that I can refer to what we are talking about. Like for example here, I don't know whether can you see my screen? You can see my screen. You're asking what does N mean here?
Yes.
No, here N means what we call observation. It means observation.
Yes.
So N mean here simply means observation. If, for example, okay, let me just go through an example. Let me go. Like you see in this example, no, this one is for probability. Yes. Now that one won't be of essence a lot. Well, let me check whether I got a question there.
We haven't done an example on population and sample yet.
Wow, okay. No, I don't know whether your question bank has a question. That would be very good. In case you
as long as I know.
Okay. So let's then check the question bank. We see whether they can have that question. That is